we go. All right, so guys, we are starting a new section, section 2.8. Then we're going to do section 2.6, and then we're done with chapter 2. So by the end of this week, probably, we'll be reviewing chapter 2, and then early next week, we'll take a test on chapter 2. Chapter 2 is usually not that bad. It's slope, it's graphing lines, it's writing the equation of a line, graphing inequalities, and then absolute value is the last one that we haven't done yet, okay? So today's notes are pretty basic. In a nutshell, what you're going to be doing today is graphing a line and then shading on one side of that line, because an inequality always has lots and lots of answers to it. So the only way to show all of the answers to an inequality is on a graph and then using shading. All right, so I've given you guys a list of steps as to how you're going to graph a linear inequality. Step 1 is if you want to graph a linear inequality, it's a line, so you want to be able to graph that line. The best way to graph a line is by getting it in y equals mx plus b form. So the first thing you want to do is solve the inequality for y. Just be careful, because you are solving an inequality. So guys, if you divide both sides of an inequality by a negative number, you got to flip that inequality symbol, so don't forget that, okay? Step 2, and you're going to graph it. Use your slope, use your y-intercept, graph the line. The only thing you have to watch out for is when you go to connect your dots to graph your line, you may be using a dashed line or a solid line, depending on what the problem asked, and I'll make sure I address that when we get to it. All right, then you're going to shade where all of the answers are, okay? Which basically means you have to shade on one side of the line that you just graphed. All right, just to give you a heads up, if the problem uses a less than or greater than symbol, that means the points on the line itself are not answers. So you're not allowed to include them as answers. So the way we show that these points are not answers is by using a dashed or dotted line, not a solid line. All right, and then if the problem uses a less than or equal to or a greater than or equal to, then the points on the line are included as answers. You're allowed to be equal to the points on the line. So then you want to use a solid line to show that those points are included as answers. To me, that's the most annoying part, because we're so used to graphing a line with a solid line that sometimes we forget and we get caught up in the moment and we forget to make it a dashed line. All right, so here we go. Let's try example number 1 together. It says to graph the following solution sets. So basically, guys, we have to find all of the x and y values that are going to make this a true inequality, a true statement. Well, like I said, there's so many answers to this problem that we couldn't possibly write them all down. We're going to show them on its graph. All right, so step 1 said to solve the inequality for y, right? So we could graph it using y equals mx plus b form. But guys, do you guys agree that this is already in y equals mx plus b form? Yeah, so our slope is negative 2/3, and our y-intercept is 3. So guys, we're good to go. Let's graph this. Let's put our y-intercept on our graph at positive 3. And then let's use our slope to move. So I think of this as a negative 2 over a positive 3. So rise over run is down 2 and right 3. Now you could keep going down 2, right 3, down 2, right 3, or we could do the opposite and go up 2 and left 3. Okay, here it is. Guys, this problem is specifically asking for y to be greater than all the points that make up this line. That's what our answers are. Because we solve it for y, we're always compared to the y value. So we want the y value to be a number that is greater than all the points on this line. But I don't want y to equal the points on this line. I just want y to be a number greater than the points on this line. So now this line is just going to be a boundary. He's not going to include any answers. So to show that none of the points on this line are answers, we use a dashed line to connect them. Okay, so basically what your line does, guys, is it cuts the coordinate plane in half. You now have this side of the line, and then you have this side of the line. We have to shade on one side of that line. Where are the answers? Well, guys, we want y values that are greater than the points on this line. So go to your y-axis where all your y values live. So here's your y-axis where all of our y values were big. Your line cuts it in half. I now have y values getting bigger and bigger and bigger above your line on this side. And now I have y values getting smaller and smaller and smaller below your line on this side. So if you want y to be greater, you want where the y values are above the line. So where is the y-axis above your line, where the y values are getting bigger? On this side right here, where y is above our line. So that means we want a shade on this side of the line. So any point that falls on that side of the line is going to make this statement true. And it also means that any point that is not on that side of the line will not make this inequality true. So normally the line is fine. It's the shading that gives the students the most trouble. So if you think you're going to struggle to see where y is above or below your line, then what you can do is pick a really easy point to test. So if you ask me, it's okay, thanks, Angel. If you ask me, the easiest point to test is 0, 0, because it's a really easy number to plug in for x and y. So guys, you see how 0, 0 is clearly not on the side that we shaded. So 0, 0 is not an answer to our problem. 0, 0 should not make this inequality true. So as long as we plug 0, 0 in and it doesn't make our inequality true, we know we shaded on the correct side. So guys, you can test it really quick. Plug 0, 0 in. 0 greater, negative 2/3 times 0 is 0, and then plus 3. Is 0 greater than 3? No. 0 is less than 3. But it's good that it doesn't make it true because it's not on the side that we shaded on, so it's not an answer to this problem. So it shouldn't make this inequality true. All right? And then again, if you wanted to pick a point that was in the shaded area, plug it in. I'm telling you right now, it's going to make your inequality true. Guys, watch this. Let's do this one. See that point right there? He's clearly on the side that we shaded. That's the point 0, 0, 6. If I plug 6 in for y and 0 in for x, it's going to make this equality true. So 6 goes in for y, greater than negative 2/3 times 0 is 0, and then plus 3. Is 6 greater than 3? Yeah, because that's a point where we shaded. Those x and y values will make our inequality true. So if you're ever struggling to see what side to shade on, pick a point, plug it in. If it makes the inequality true, shade on that side. If it doesn't make the inequality true, don't shade on that side, shade on the other side of the line. All right, let's try another one. Okay, so guys, look at example 2. Now we have to graph this solution set. So first things first, if we're going to graph it, we got to solve it for y. So let's solve for y. Let's take our 1x and let's minus it to the other side. Positive 4y is less than or equal to, I can't combine them, so let's separate them. I'm going to put my negative 1x first, and then my minus 8. The only thing you have to do to get y by itself is divide by 4. Which, guys, that means you have divided both sides of an inequality by a positive 4. No reason to flip that symbol. So y less than or equal to negative 1 over 4 does not divide or reduce, times x, negative 8 divided by 4 is negative 2. Okay, so we're trying to find all of the y values that are either less or equal to the points on this line. So let's graph the line. Let's get our boundary line. So negative 2 is my y-intercept. And then my slope, negative 1 over positive 4. Rise over run. Down 1, right 4. Or instead of going down 1, right 4, let's go up 1 and left 4. All right, do we want a solid or dashed line? I want y to either be a number that is less than the points on this line or equal to a number on this line. Since y is allowed to equal the points on this line, we can include them as answers, so a nice solid line. All right, so again, your line literally cuts your coordinate plane in half. You have two sides. You have this side of the line or you have this side of the line. Which side are we going to shade on? Well, we want y to be less. So we want y to be below our line. So we got y values getting bigger and bigger and bigger above our line on this side, or we have y values getting smaller and smaller and smaller below our line on this side. So if you want y to be less, shade where y is below your line. And it's below your line on this side. So any point that falls underneath this line will be a solution to this inequality. And again, 0, 0 is just an easy point to work with. 0, 0 is not on the side we shaded. So if you wanted to plug it in, as long as 0, 0 does not make the inequality true, we know we're correct. All right, but I'm telling you, we are correct. All right, let's try one more. Let's try this one. What if they want you to solve this inequality, right? Well, let's solve it for y. Minus 5x to the other side. We get negative 2y is greater than, I can't combine them, so I'm going to put my negative 5x's first and then my plus 2. Okay? And then all I have to do is divide everything by negative 2. But that means you just divided both sides of an inequality by a negative number. You're going to have to flip that symbol around. So now y will be less than negative over a negative is positive, and 5 over 2 does not divide or reduce. Positive 2 divided by negative 2 is negative 1. Okay, so let's graph our line. Let's get that boundary line up. So we're going to go down 1. And then our slope is 5 over 2. So rise over run. Up 5, right 2. Or instead of up 5, right 2, go down 5 and left 2. All right, solid or dashed line. I only want the y values that are less than the points on this line. I do not want y to be equal to any of these points. So these points are just going to be a boundary between our answers and our non-answers. So we're going to use a dashed line. Okay, so again, now we have two sides. We have this side of the line where it looks like y is getting bigger and bigger and bigger and bigger above it. And then we have this side of the line where y is getting smaller and smaller and smaller below our line. But what do we want? We want y to be less. So we want a shade where y is below our line. So y is getting smaller and smaller and smaller below our line on this side. So as long as x and y are a point on this side of the line, it will make this inequality true. Guys here, how do you feel about this? Is everything okay? Usually it's just the shading. The graphing, no big deal. Everybody graphs fine. It's the shading. Students really struggle to see which side to shade on. Guys at home, how are you guys feeling? Is the shading okay? Are we all good? All right, what I'm going to do now is the last two examples, they're horizontal and vertical lines. They're not on tonight's homework, so I'm not going to do them today. I'm actually going to switch over to Delta Math right now and show you what this looks like in your homework so you know what buttons to press, okay? So let me just get Delta Math up, and we'll do a problem over there.
So I'm going to click on the stuff when you do it?
Yeah, if you want. Perfect.
I don't know how to do it, so you're going to tell me.
You're going to see, yeah. No, it's fine. It's perfect. I'm going to explain to them too. All right, so guys, this is what it's going to look like on Delta Math. You're going to have 10 problems like this. It says graph the inequality on the axes below. So we're basically graphing the solutions to this inequality. Let me just write it over here so I can have room to solve it. Because something's going to pop up right here that I want you guys to see. Okay, so first things first, we got to solve it for y so we can graph it, right? Some of them are going to be solved for y and some of them won't. So just, take it whenever it comes up. All right, so let's solve this for y. So let's minus our 1x over. We're going to have negative 2y is less than, can't combine them, so let's put our x's first, negative 1x and then plus 2. And the only thing you have to do is divide everything by negative 2. But if you divide everything in an inequality by a negative number on both sides, you're going to have to flip that symbol around. So don't forget to flip. All right, so y, symbol flips, negative over a negative is positive, doesn't reduce, so it stays 1/2 times x. Positive 2 divided by negative 2 is negative 1. Okay, so this is what we're gonna have to graph, right? So technically, delta math's gonna do everything for you. So the first thing you're gonna do is get your y-intercept. It's -1. So you're gonna click on -1. A black dot will magically appear once you click on it. Now, Ms. Greenhouse, move your cursor around. As soon as you click on your first point and you start moving your cursor, a line in gray is automatically going to appear. All you have to do is use your slope to move to your next point. So we're gonna go up 1, and we're gonna go right 2, and you're gonna click again. Now, when you do that, 2 things happen. Number 1, a line automatically appeared in black and yellow. It will always pop up as a solid line first. If you notice, underneath your problem, the minute you click that second point, 2 buttons will also appear. A change line and a change shade button. So the first thing you should notice is, wait a minute, we want the y values that are greater than the points on this line, but not equal to it, which means we don't want a solid line, we want a dashed line. So to get a dashed line, you hit the change line button, and it'll change it to dashed. And then if you're like, oh crap, I want it solid, hit it again, and it goes back. And you're like, nope, I was right the first time, hit it again, and it goes back. So just keep hitting the change line until it's solid or dashed and you're comfortable with whatever the answer is. Now you're shading. If you try and click like up here, nothing. Nothing. You try and click down there, nothing. To get your shading to appear, you have to click the change shade. Now maybe that's where we want it, maybe it's not. If you click it again, it'll go below the line. If you click it again, it'll go back up. So you just keep clicking it until where your shading is. Well guys, we want y to be greater than the points on this line. So we want to shade where the y's are above our line. So we got y values here getting bigger and bigger and bigger above our line on this side, and we got y values getting smaller and smaller and smaller below it on this side of the line. So if we want y to be greater, we want to shade where y is above it. So on this side, that's the side we want. So perfect. Now you just scroll down and you hit submit answer. And then you hit yes, and you get your green check mark. Easy enough? Yes? Okay, everybody good at home? All right, perfect. So you're gonna have 10 of those questions for homework tonight on Delta Math. It is due tomorrow night at 11:45.